When you stop and think about it, Earth is pretty special, right? We're living on this amazing blue marble that's just perfect for life. Meanwhile, all our neighbors in the solar system are either boiling hot or just frozen solid. So what's our secret? What makes this planet work? Let's dive into the invisible shield that makes it all possible.
And really, it all boils down to that one single question. Without some kind of planet-wide climate control, Earth would be completely unlivable. So what is that system? Well, the answer is floating right above our heads. It's our atmosphere.
Just take a look at the moon. It's right there, our closest neighbor, getting pretty much the same amount of sunlight we do. But here's the thing, it has no atmosphere, so its average temperature is a bone-chilling -20 degrees Celsius. Earth, on the other hand, is chilling at a comfortable 15 degrees Celsius. That's a 35-degree difference, and that's all thanks to that thin layer of gas. That's the real hero of our story.
And that brings us to the perfect analogy for what's going on. You can think of Earth's atmosphere as a natural blanket. It's this incredibly fine-tuned system that has kept our planet warm and stable for billions of years, really, allowing all kinds of life to evolve and thrive.
This whole process has a name, the greenhouse effect. Now, it's so important to get this first point straight. In its natural state, the greenhouse effect is not a bad thing. In fact, it's absolutely essential. Without it, our planet would just be a giant ball of ice.
So, how does this planetary blanket actually do its job? It's actually a pretty elegant three-step dance of energy. Let's break it down.
Okay, so step 1, energy from the sun beams down right through the atmosphere and warms up the ground. Simple enough. Step 2, the Earth's surface then sends that energy back out, but this time as heat. But, and here's the magic part, step 3, some of that heat doesn't escape. Greenhouse gases in the atmosphere grab it and then radiate it back down, which warms everything up. It works exactly like a blanket, trapping your body heat on a cold night.
And that's really the key takeaway from the first part of this. For millions and millions of years, this process has worked like a perfectly balanced thermostat, making life on our planet possible. So the effect itself isn't the problem. The balance is everything.
Which, of course, leads us to the big question. If this is a natural, life-giving process, then what's the deal? Why is the greenhouse effect something we talk about like it's a massive global problem? What changed?
Well, the problem isn't the blanket itself. The problem is that we've been thickening it a lot. This is what scientists call the enhanced greenhouse effect, and it's basically an imbalance that's been driven by human activity ever since the Industrial Revolution kicked off.
See, we're pumping extra heat-trapping gases into the air. The big one everyone talks about is carbon dioxide, CO2, which mainly comes from burning fossil fuels like coal, oil, and gas. But there's also methane from things like agriculture and nitrous oxide too. All of these together are making that blanket thicker and trapping more heat.
And this chart, this is basically the smoking gun. For hundreds of thousands of years before the 1750s, CO2 levels in the atmosphere just hovered right around 280 parts per million. And now, look at where we are today. We've blasted past 420. We have fundamentally changed the chemistry of our atmosphere in what amounts to a geological blink of an eye. And the physics are simple. More greenhouse gas means a thicker blanket, and a thicker blanket traps more heat.
So what's the direct result of making that blanket thicker? Well, you get a planet that is steadily, measurably getting warmer.
And this is what we call global warming. It's not about one hot day in July. We're talking about the long-term heating of the entire climate system, a trend that's directly tied to that spike in greenhouse gases we just saw.
And the effects of this warming are huge. They're everywhere. It's not just about things getting a little hotter. We're seeing big shifts in weather patterns. Ancient glaciers and massive ice sheets are melting way faster than they should. And because of that, our sea levels are rising. It's all connected, one big cascade of consequences.
This quote really just sums it all up perfectly, doesn't it? The natural system is still there, doing its thing, but by adding all these extra gases, we've essentially grabbed the planet's thermostat and cranked it way up without really knowing what all the consequences would be.
So there it is. The science is pretty clear. We understand the basic mechanism that keeps our planet cozy, and we can see exactly how we've altered that system. The physics of it all are settled. So that leaves us with the most important question of all, one that science alone can't answer. Now that we know we're in control of the thermostat, what happens next?